Hello there, future coding masters. Welcome back to my special playlist, Conquering the JavaScript Interview, the Bitwise Basics Edition. In this episode, I'm going to dive into a challenge we've done before on this channel and in this playlist called swap nums, or swapping numbers. Except the requirement in swapping number values is that we are not allowed to use a temporary third variable to store a value, which makes it easy to do and pretty clear and readable, but we're going to learn how to do it, not like in the last video, which if you're interested, you can go find the link in the description down below for that. But I'll showcase the code here as well to show the similarities. But instead, in this video, we're going to be focusing on how to do it with, you guessed it, bitwise operators. So this little bit of magic bitwise wizardry will make you interview ready. But first, let's talk about transforming your coding journey with where I work here at Covalence. Imagine having access to 300 hours and more of meticulously crafted lectures, walkthroughs, drills, and labs. So whether you're looking to master front end, weave through the complexities of back end, or conjure up powerful web applications with React, Covalence has got you covered. Combine our front end and back end courses, and voila, you're looking at the entirety of our full stack development program. It's not all. You're going to get some lab reviews and a supportive Discord community where you can also harass me for new video ideas, content, and help along your journey. Now, back to the task at hand. Swapping numbers sounds simple, and it is, honestly. Without a temporary variable, a little bit more complex, but if you know the arithmetic trick, it's also not that bad. But doing it with bitwise operators, well, that's a little bit of magic and a little bit of understanding, and the code is very easy to memorize when you see it. So like I said, our goal here is to write a function to swap the values of two variables without using a temporary variable. Basically, we're going to be expecting two integer values, a and b, and represent the numbers to be swapped, and the output should be the two numbers or the two variables exchanging their values. Our constraints for this video: don't use any additional variables for storage, including not using array indexing or object properties as temporary storage. None of that. Assume the numbers are within the safe integer range for JavaScript, which is like 2 to the 53rd minus 1 or something like that. And yeah, that's it. So our examples are straightforward. If we have like 5 and 7, we should see 7 and 5 after the output. I mean, it really isn't all that complicated in terms of a problem, right? But remember, due to how JavaScript does pass by value for numbers, we have to demonstrate the swap within the function or involve the use of an array or object to hold the numbers so we can see the effect outside the function scope. For this video, I'm just going to console log the values inside the function. Again, if you want reference versus value, look it up on our YouTube channel. I should have a video on that here, but if not, I can make a new one for 2024. Get in the comments down below and let me know if you want a deep dive on a cool subject, like primitives versus reference data types, and that's where we get pass by reference or pass by value into functions, which is something that comes up all the time. And again, you've probably written and done a lot with it, but seeing it is a whole nother, and seeing it and defining it and being able to give an example in an interview would be a good skill to have. So in the interest of time, it's already been 3 minutes in. Let's go ahead and get going here. I'll bring up my terminal. There we go. I think I can zoom out one level and get away with it. Yeah. So, okay, we got our function ready to go here, as in we're going to go ahead and write it. It is very straightforward in terms of code. So we're going to console.log before and then an object with a and b. We're going to use a little bit of shorthand right here. So for example, if I call swap nums with 5 and 7, which are values, I'm just using a little bit of shorthand of writing a:\a, which we know in ES6 shorthand. If the key and value are the same variable name in JavaScript, you can shorthand them down to that. It's something I do all the time when it comes to quickly logging something for my own sake. So now we're going to have a before and after console log ready to go. As of right now, there's no swapping logic, but check it out. I think you already know what operators we're going to be using in this particular video due to my dead giveaway up here in the diagram you can see in my tab here, but that's okay. Because if you don't recall about XOR, it is fairly straightforward. It compares two digits and yields 1 only when they are unique. Remember, this is the exclusive OR gate, typically demonstrated with this little bullet type shape with a little panel at its butt end right there. A and B come in as our inputs, XOR together, we get the unique exclusive OR of them, meaning the only way we get a 1 output is that they are both unique. So the same number doesn't matter, the same 0 doesn't matter. The only way we get 1 as an output is if they are two different numbers, so either 0 and 1 or 1 or 0. Remember, this is our crossroads analogy. we have a conductor at a crossroads, and we'll only let them pass if bit and byte, our two friends in this analogy, go in different directions. So zeros together indicate them standing still. It is no go, doesn't work. The two of them going in the same direction also doesn't work. It's like, no, you can't do that. But going in two different directions is an okay by our crossroad guard, the XOR operator in this analogy. So it is very, very straightforward. Check this out. We're going to A XOR B. We're going to reassign B to be the newly assigned value of A XOR B again. And you guessed it. That's it. So in this 3 simple lines of code, which I think is extraordinarily simple for you to memorize and output in an interview should you get a swap nums without a temporary variable type question in an interview. Again, this is like less web development and more like general computer science knowledge for this particular implementation compared to the arithmetic one. But nevertheless, I think this is simple to memorize. Just remember ABBA and then A XOR B 3 times. That's it. So ABA, A XOR B for each one. And guess what? If you know your rules of XOR, you can demo this in a set of comments or write it out in paper or your whiteboard or your notepad if you're on a Zoom type interview or something like that, like a webcam one. That's it. I mean, it gets the job done. If I save the file, check it out. Our before is 5 and 7, and our after is 7 and 5. So it successfully swapped the numbers with 3 simple lines of code. And the same operator in a whole 3 lines, which I think is pretty cool. For a quick reminder, the implementation to do this without the XOR or bitwise operators was taking A and assigning it A plus B. You take B and then you subtract the new value of A and minus B, or its current value, because remember in JavaScript, the right hand will evaluate first and assign to the left hand. So this will be A's new value, which is A plus B, which means if we subtract B out of it, then we are left with only A's previous value, which we store into B, and then that is going to be then reassigned into A with B's new value. And this little arithmetic trick, as you can see, I saved it right here. Exclamation point to show y'all right there, so I have the same amount of numbers and letters. That's more even now. It is in fact working the same way. And I mean, you know, in an interview, if you don't remember this arithmetic trick right here, you might try and memorize it's plus, minus, minus in that order right there, which is totally a fine way to do that. But I think the bitwise way is even easier and will show your interviewer the ability of how hard you can flex with your fundamental computer science knowledge. So let's go ahead and see how this breaks down, right? So that first line of code, that A equals A XOR B. We are taking and combining A and B with a XOR operation, and we stored that result back into A. The effect of this is that A will be a unique combination of bits from both A and B. Remember, it's XOR, the unique bits. At that point, it holds the difference of the bits between A and B, which is crucial for the next step. So this first step, line 36 in my window, A XOR B on the initial line reassigned to A, right? We get the unique bits, which is the difference between the two. Now the next line is the new value from the previous step, A, and we're going to XOR that again with B, which has not been changed yet on my line 37 on the right-hand side of the assignment operator. Right? Since A was A XOR B, XORing it with B essentially reverses the operation for B, isolating the original A bits and assigning them to B. Mathematically, since XOR is its own inverse, B ends up with A's original value. Remember, in our diagram, it's important that it's commutative, meaning it doesn't matter in the order of 0 XOR 1 is 1, and also 1 XOR 0 is 1. So again, the order is not important. It'll get 1 either way. Now, you should probably go back to the code before I keep talking. So that's what's happening there, right? Because XOR is its own inverse, B ends up with A's original value and reassigns it to B. Therefore, B is now A's value. So all we have to do is the final line of code, 38 in my code editing window there. We take the updated A from step 1 and XOR it with the new B from the line 37 in my code editing window. This step uses the fact that B now holds A's original value, and it gets us B's original value, completing the swap by XORing it with B's new value, which is A. Oh my, this is so difficult to say out loud. So again, because B is now A's value, XORing it with A, which is the new value, we get B's original value, which completes the swap. So again, I'll show you this in comment form as always. But the key points are, remember, XOR is used because of its unique properties. It's commutative, associative, and its own inverse, right? That's what I was showing y'all on that diagram. The order doesn't matter. It will always get you the same thing. And it relies on the fact that any number XORed with itself results in 0, and any number XORed with 0 results in the number itself. So the sequence of operation effectively transfers the bits of A and B between the two variables without any need for intermediate storage, illustrating a very elegant solution using bitwise operators for direct value manipulation. So, as a TLDR, remember I give out this in every one of these videos since these are fairly complex and hard to remember. Bitwise operators are like control switches for Christmas string lights, where each light bulb represents a bit in a binary number, off, 0, on, 1. So just as you can create patterns by turning off and on or flickering bulbs, for example, bitwise operators let you manipulate individual bits of data in binary numbers. We have AND, which is like checking if two lights are in the same position, or turning on a light if either or both of the two lights are on. XOR, like toggling a light only if exactly one of two lights is on. NOT, like flipping on all switches if a light is on, off, etc. We have left shift, moving all the string lights to the left, right shift, moving all the string lights to the right. So they're used in efficient data manipulation, these bitwise operators. Setting flags is very common, encoding, decoding, blah, 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 blah. I mean, I have the same spiel every time about these things. Yeah, they're like in cryptography, digital signal processing, graphics rendering. Yes, you guys and gals understand what these things' purpose is. But in terms of how it works, let's try and, like I said, break this down in a set of comments. So just like I always do, we're going to go ahead and start off with the following. Our initial input is 5 for A, which means that is 101, which is 5, right? Because we have 0, 1, 2, 3, 4, and 5, okay? That's how we get there in counting in binary. Remember, it's base 2, so every time we get to a 1, we go to the next bit. B has an input of 7, so if that's 5, then that means that would be 6, which means 111 would be the value in binary in the 7, and that's what we're looking at for our two inputs. Remember, each line of code is fairly straightforward in that it's just XORing A XOR B for every single line. In this case, before we reassign A, our input is 101. Our B input in this particular line of code is 111. We're going to XOR these two columns of bits together. Not unique, unique, not unique. Therefore, we get 010 as our output of the XOR operation, and that is reassigned to A in this particular case. The next line of code is B equals, or assignment, A XOR B, and now we get A, which is now 010. Remember, this is now the new value of A, the difference between A XOR B. And then our current B, which is still 111. We're going to XOR those two numbers together, and then we're going to get unique, not unique, unique. And that's going to be reassigned to B. And would you look at that, 101 was the original value of A, and now it got placed over into B. Very convenient. And then finally, our last line of code is the same thing, A equals A XOR B. Remember, the current value of A is 010. The new value of B from the previous line of code is 101. If we XOR these two numbers together, we get unique, 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 and we reassign that to A, meaning the final output is line 58 and 64. We get an A of 111, aka 7, and then we get a B of 101, aka 5, aka the numbers have swapped, right? Because it was 5 and 7 when we started this little adventure here, and now we got 7 and 5 as our respective outputs, which is exactly what we expected to see. I could do this with other numbers, but I mean, feel free to do so yourself. Drop comments down below of using your own input numbers or whatever to try and demonstrate. You can go through these comments. You can write out these comments in an interview setting to explain to your interviewer how this magic actually works. So, beyond memorizing 3 very simple lines of code, I think being able to write out comments of how it works would demonstrate such a fundamental understanding to your interviewer that you, again, would look really cool in an interview. And that's really all what it's all about, folks, right? So there you go. That's how it's all pieced together, a TLDR, bitwise operators, the big O, including both of these, by the way. So both the previous version I showed you, which was the arithmetic it was a plus b, a minus b to get to the same solution using simple arithmetic and not worrying about bitwise stuff. They both have a time complexity, big O, time, big O of 1, and they also have a space, big O of 1, meaning, how do I zoom out? Oh my god, it's control, that's right, yeah. I knew how to do that. So we get a big O of 1. So on our crazy looking graph here, we had the big O of 1, the flat line down at the bottom. No matter how big the input gets, because we're using no additional any space, it's just going to be it's a swapping technique that operates in constant space because they use a fixed amount of space. There's no additional structures. There's no additional structures like objects or arrays or anything like that we have to assign there in terms of the space used. They both have a big O of 1 time because they both perform a fixed number of operations, exactly 3 XOR operations in this case, regardless of the input values of A and B. Similarly, the arithmetic swap version performs a fixed number of operations, a plus, subtraction, subtraction. So that's it. So regardless of what the input values are, they both have the same time and space complexity, which is unique because a lot of the times when I showcase an algorithm that uses bitwise, it is a stronger, more efficient algorithm compared to its non-bitwise complement, so to speak. But again, this is about learning this cool technique, understanding further how XOR works. It's a really cool one and one of the more complicated ones, or at least it can be. So again, it's very cool to know how to do this, right? So like I said, I've told y'all a lot of common uses for this stuff in terms of encoding, cryptography, signal processing, blah, blah, blah. But remember, this is closer to how computers actually process data. So you're just this much closer to understanding how that little square inside of your laptop or your desktop, that little square you smash into your motherboard and you're afraid you break all the pins when you cram the lock down on the motherboard. If anyone's built a PC, get in the comments and tell me if you also clamp down the lock on the motherboard for your CPU and you thought you broke it because of the horrible crunch sound it makes. Anyway, knowing how to do this, always performant, always space efficient, and it really helps general algorithmic thinking, including how to solve problems, seeing patterns that you can solve with bitwise operators, aka really flexing on an interview if you could shoehorn these in. Prepares you for interviews by giving you some out-of-the-box solutions that can really showcase your fundamental understanding of computer science should you not have that kind of background. Man, my background from schooling was a lot of biology, pre-medicine work, which I don't use much here other than knowing that at Covalence, I know what a covalent bond is. Right? That's useful, I suppose. And then, general system internals and broadening your knowledge and things like that. Just your general things when it comes to this code. So yeah, that, dear viewers, wraps up this journey in our fascinating world of swapping numbers that a temporary variable, including the old version, now the new hot version to do it instead. With a few lines of code, you can unlock these powerful operations and really show off the elegance and efficiency that you understand with bitwise operators. So don't forget to check out Covalence in the description down below. We have a link to our community membership in our Discord channel as well. I'll have a link to a code pen that has this prompt in there, as well as the final written code. And I'll have an Imgur link for the XOR operator if you need it as well, and a link to the previous video that talks about the arithmetic challenge of swap numbers. So I explained how that math works out in that video. So if you found this helpful, give us a thumbs up, share with your friends, subscribe for more content designed to help you conquer them interviews, as well as any other tutorials I have coming up on the way. I got a couple ideas for new videos because I'm getting kind of tired of doing bitwise videos myself. So until next time, keep coding, keep exploring, and never stop learning. Happy coding.